Hello Year 11 and welcome to this, the third video here for our second topic. We're looking at real numbers and approximations today. Now, a real number is any number that could be marked on a number line. So, it can be an integer, it could be a rational number, it could be an irrational number like pi or root 17, I don't know. Those things are all real numbers. All measurements are only ever approximate, and so we always end up rounding them off to some extent to give some level of accuracy. Scientific notation we use for very large and very small numbers, such as maybe the distances between stars or between protons. Perhaps really big and really small things, we end up with either a fabulous number of digits or decimal places. With scientific notation, we always express our number initially as a decimal, as a rational number, with between 1 and 10, usually with a certain number of decimal places, and that might be specified, it might not. So we choose a number between 1 and 10, and then as the product, or times a power of 10. So it's something, point something, times 10 to the power of something else. Let me show you here with this first example. This is 3,200,000, which is a little bit of a mouthful. Certainly more compact to express that as 3.2 times 10 to the power of, right, how many times I've got to move the decimal place? 6 times 10 to the power of 6. Right. So you can see we've got a number here between 1 and 10 and multiplied by a power of 10. Over here, this is going to be equal to 5.4. Oh, it says to two significant figures. Right, that's fine, that's two significant figures. It's going to be 5.5, because I've got to round it off. 5.5 times 10 to the power of, now 1, 2, 3, 4, 5, 6, 7. So 10 to the negative 7 in this case, because we're moving the decimal place to the right. So there we go, and I should say approximately equal to there, because we've rounded it off. 5.5 times 10 to the negative 7. That's how we use scientific notation. Irrational numbers cannot be expressed as the ratio of two integers. They can be very difficult to express in their exact form. Sometimes we need some sort of geometrical description, such as the square root. Not all of them can be expressed that way. The square root of an integer that's not a square number, like 1 and 4 and 9 and 16, 25 and so on. Those also square root of any non-prime, or for that matter non-square, is going to be irrational. We call them SERDES, and we are going to look at those in the next video. That'll do us for now. Okay, if you've got any questions about real numbers and approximations, jot them down, let me know. I'll see you in class.